we're going to do some coding again to solve this problem. Okay, so how do we start when we write a script? Yeah, you can do, but personally I don't. It's good practice though, I should. Yeah. Yeah. We think about what we want to do in the script, right? What's the first thing? So remind ourselves, okay, for this script we want to run a blast and pass the results. Right, that's the overall aim. So yeah, what can we think of as if we break this down into steps? What are the steps going to be? Yeah. So usually I say read in the data because import in Python means something quite specific about importing a module. But yeah, so step one, we're going to have to read in the data. Step two. Yeah. Step three. That's probably, so what I always like to start with step one because you always forget one and have to go back and add it in before. So step 0 will be import the modules. That's the first thing we have to do. So, kind of implied in that is we're going to have to find the modules we want to use, right? Okay, so we're going to import the modules, we're going to read the data, we're going to make the database. What's next? Yeah, run the query, yeah. Sorry, is this big enough? Yep. Pass the XML file. Yeah, like print the output, print the output, right? Okay, so now we've got this idea of what we want to do, and each of these is apart from the 0th one is kind of a natural function. So it's really sensible to use functions in your Python coding. It makes the code much cleaner and simpler, easier to adapt. And kind of when you come back in 6 months and you need to figure out what's going on, if you split everything into functions, then it's much easier to understand. And it kind of goes very nicely with this idea of thinking about what we want to do beforehand. Because each of these steps is a kind of distinct step that lends itself to being a function. Okay, so we're going to define a function called read in the data. What inputs is this function going to need? Yeah, like the handle, right? Okay, so are we actually going to need to read in the data here? So when you were using those blast things, did you actually have to read the data directly into Python, or did you just pass a file handle to the BioPython function?
get past it directly.
Yeah, so maybe we don't need to do this actually. But we do need to specify the file handles. So again, we're going to use this pattern of having a main function. And we're going to have our flyC handle and our fludgB handle, which, for sake of sanity, I'm just going to copy. I'll get the database handle too. Okay, so we've got these three handles, and they're all in our in the directory we're currently working in. Here's the script I'm working on. fludgB, flyC, and the reference genome are all there. So we can just use this kind of path. We'll find those files. So those are all exactly how we want them. Okay, so make the database. So I'm actually going to cheat a little bit. So firstly, I have already made them, but secondly, I'm just going to make the database on the command line. So if I'll just remove them for now, and so just yeah, it's make last DB. And then we just run it to see what arguments we need. Okay, so we don't read all of this stuff. That's too much like hard work. We read, okay, down here we're missing a mandatory value. So that sounds like something we need to pay attention to. So say db type. We're missing an argument db type, so we need to put that in. Knuckle for nucleotide. Okay, so we don't actually need to do that. So we're going to do in as well. For this. Okay, so now we have made our database. Okay, so made the database is done. So now we need to run the query. So we are going to put this inside a function. So what arguments is this going to take?
It's going to take the query.
It's going to take the command.
The command?
The command will probably be within the query. Probably won't give it. Oh, you mean like blast M, blast B, that kind of thing. Oh, yeah, we could do that. Yeah. But we're not going to right now because we kind of need to move relatively quickly. Yeah. Which, primarily is the query sequence and the database, right?
Yeah.
So we're going to run it with the fludgB handle and the database handle. So this is our query and our database. So now we define that function. We call it query and database. Okay, so we're going to use okay, so this ncbi blastn command line. So you could just do it with a subprocess. This is just a kind of slightly different way of doing it. It doesn't really doesn't make any functional difference really, but the kind of point of it was to get used to using custom modules, so we'll do that. So we're going to do our import. Okay, and then here we say very annoying. So I can see why you were missing that bit, because it's we'll come to that in a minute. Okay, so just from the documentation, this is how we run it. What are we going to put here? Yep. What are we going to put here? Yeah. We're going to get rid of this. I'm not sure what that does. Output. I mean, let's just leave the output like that for now, while we check that it works, right? So that's like a common pattern. Like, don't do everything like first time. Get to a certain point and then run it and make sure it's working as you're expecting. Because then, if you build, it's like you don't build an entire house before you check the foundations, right? You build the foundations, you check that they're okay, and then you carry on building the house. So we check that the first thing we're doing is working as we're expecting. So we can just leave that there, and we'll have a look and see if that is working or not. Okay, so here the documentation is really bad, I'm afraid. So this is not gonna, if we just put this in, it's not actually gonna run the blast. So what we need to do is we actually need to we need to execute that command. So this is the kind of headache that comes with using external libraries. So yeah, this is part of the trade-off. Whereas if you're doing subprocess, it would be, if you use subprocess, then it would be a bit, you'd probably be more familiar with how subprocess is working, so you wouldn't kind of leave that bit out. Okay, so now in order for anything to happen when we run this script, we just need to call this main function, because if we don't have that main function, then nothing happens when we run it, because just functions being defined doesn't actually lead to anything happening. We have to call the function. So we uncomment this main function, and then when we run it, looks like nothing happened, but this XML file is created. And it's got some size, it's 11 KB, so we can be like quite confident that something has happened. Okay, and blah blah blah. It's got all this so this is what XML looks like. It's a structured text language. It's kind of horrible, but quite widely used. Okay, so now we know that these two things are working. So let's get a little bit cleverer with our output name. So let's take that as a argument here. So here, because we know we're giving it the fludgb handle, we're going to say fludgb versus ref .xml. And I mean, we could do this in a cleverer way, but it's good enough for now. Good enough is good enough. Okay, run it again, check, and now we have this fludgb versus ref that's got that. something in. So we want to run this twice. And now we have these two files, flyc versus ref and fludgb versus ref, that are XML files ready for us to pass. So everything's kind of solid and we're ready to move forward. Okay, so we've done this one, tick. So now we need to do this one. So pass the XML. So this is going to take as an argument XML in handle. So why do you think I use this like word handle all the time? Why am I saying like in handle, fludgb handle, out handle? Any thoughts about why we might like call things, say things are a handle?
Because they are going to use as objects.
Sorry?
Because they are going to use as objects.
Kind of, yeah. So it's to differentiate it from the object itself. So like the handle is like the name of the thing, especially like a file. It's like the name of the file. Whereas if we said like fludgb, that sounds to me like it's actually a gene. You know, if you call an object like the fludgb, then it's like makes me think, oh, it's a sequence. You know, it's got a bunch of sequence-like properties. Whereas this is not a sequence; it's a string. It's a file path, and we call that a handle. So it's to help us remember what's like the name of a thing versus the thing itself. Okay, so pass the XML. Okay, passing the blast output. Blah, blah, blah. So if we have one record, single blast result, which is actually the case in this, but it's usually a good idea to future-proof these things. So this is what we're going to do. You see how they call it result handle as well. It's a common pattern. And so we just need to change this to match our code. And then they say, okay, so this is, again, it's an iterator. So, yeah, we're not going to go into what that is right now, but so you can either access it with two things. You can use this next function, which you rarely do in my experience. More usually you just use a normal for loop. So for blast record in blast records. Print blast record. Okay, and now we run this, see what happens. Okay, NCBI XML is not defined. Okay, what do I need to do now?
Import.
Yes. Okay, let's try again. String object has no attribute read. What do I have to do now? So let's have a look at this traceback. So it's saying attribute error. str for string object has no attribute read. Okay, so now it's happening on. This is like within the XML, the BioPython XML code. It's happening when within this function for blast record and blast records. Yeah, it's kind of a tricky. It's not obvious from this error message what the issue is. This is probably, in my opinion, the most helpful line. And this is a huge part of being able to code, understanding error messages. It's really difficult. You know, don't feel bad that this doesn't make sense. The only thing that helps you with this is experience. So this is tricky. But like, what kind of objects might have like read or write functions? Yeah. So it's telling us, okay, well, we're trying to read this object, but we don't have. This is not an object that has an attribute read. So it's telling us, once we know how to interpret it, that we've passed a string where it's expecting a file. And if we look a bit closer, doesn't make it obvious. So again, the documentation is not great. Okay, here we go. So the result handle. So we didn't read the documentation properly, and result handle is actually a file. Open function returns like an open file. So we have to open this. And now that turns that string into a file, and then files have read attributes. Okay, so now we have this thing that's working. It's a blast record, but it's not particularly helpful. I mean, you know, I think a lot of you yesterday on Monday, Tuesday came across this. You print something and you hope it's going to be helpful, and it's like this kind of, you know, okay, great, I've got a bio.blast.record.blast object at some random like hexadecimal thing. So this is what you get when you print just a whole object. Just like an object, this is like the object itself. The whole object. So whenever you see this kind of thing, then this is when that dir and vars come in. Okay, so this is showing us two things. Firstly, this is the dir output. So copy it into a text editor. Personally, I find it very hard to read this kind of thing. So I just use the regular expression part in the text editor to replace all the commas which separate the things with new lines. And then this is like a bit more easy to read, or you could just pretty print it. Okay, so now these are all the attributes that our class has, which, you know, could help us. You know, if we have lots of time to dig through all of these and kind of poke and prod each one, we could print each one. Okay, so we see that it has query ID. That sounds like it kind of might be quite useful. So now now we print the query ID. Okay, and it's a very helpful query one. So that is, if the documentation is no good, this is like what the code is actually, all the methods that are actually available. It's a really helpful thing to do the code, so we're going to do the same here. Okay, so now this is a bit more interesting because this has the values as well as the keys. So previously it shows us the methods and the attributes, but here it's showing both the attributes and the value that they have. So we can see that, the database name, some information about the database, blah, 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 query length, lots of different information here that is kind of much more sensible, much more kind of interpretable, but both of them are useful. Okay, so, and then just to kind of make it clear, we can take those things from that and use them as they're the attribute names of our class, so we can access them with the doc syntax. Okay, so we've only got a couple of minutes left. So we're just going to I'm just going to cheat a little bit, and also this is in the documentation. And we say, okay, for alignment in record.align. So if the record has alignments, which if we look, oops. Okay, so it does have an alignment. So these are the alignments, and they're the value. It's again a dictionary where the value is a list of classes, another class, an alignment class object. So it's true that record does have alignments. Then we're going to iterate through those alignments. And then if we looked at that alignment class, we would see that it has an attribute called HSPS. So we're going to iterate through those. So this is like why it's tough to get to grips with external modules, because they do things in like ways that are designed for you to be able to do very flexible things, but flexibility does not lend itself to ease of use. If something is like super flexible, then it's difficult to use because you can do anything with it. So it's kind of easy to get lost. So this is like part of the trade-off with using external modules. And then I'll just make the code available for anyone who's interested, but basically we can get all of the information we want from these different records. Okay, so I called it something else previously. Okay, and now like it's printing out the things that we wanted to print out. That come from a variety of different places and that aren't all available in the normal BLAST output. So, yeah, I think this is a fairly straightforward. It's like kind of it's not the easiest use of an external module, but nor is it like the most complex. So this is kind of a fairly representative taste of what you're going to get if you try and dip into an external module. So I think you've all had some experience of it is painful. It is a steep learning curve getting to grips with these things, but then as a trade-off, you get kind of quite a lot of power, quite a lot of tools in your armory. Now we could, we could have a web server. We could put this within a kind of web server application and let people do blasts on like a local database. That if the web server was running in Python, whereas if we weren't using like native Python implementation, that would be much more awkward. That would be one example. Or just sometimes it's nice to keep everything in one coding language rather than switching back and forth to the terminal. This is just one example of that. But yeah, lots of others out there for all the external modules. So I guess part of the lesson of this is like think twice before you jump into an external module. But when you do, you can unlock quite a lot of powerful functionality. Okay, thank you. It's lunchtime. And that is the end of our advanced stream. We're going to combine with the other guys this afternoon.